Welcome you, sir. Dr. Sheikh Mohammed Sultan from University Technology Brunei is with us online. He is the backbone of this collaboration. We already conducted one international conference, and this is the second program in sequence. On behalf of the Department of EEE, I extend a warm welcome to our dear Dr. Sheikh Mohammed. And it is the third FDP organized by the department under TechUp 2 funding. We also conducted one staff development program, and also one more is planning during the second week of March. Moreover, 2 to 3 soft skill training and the technical training sessions and industrial visits are also organized by the department. All these are possible with the TechUp Phase 2 funding. I'm happy to welcome our TechUp 2 coordinator, Dr. Adarsh, to this function. And all of you know the speciality and relevance of the topic of our FDP. All of you know that the classes and labs are running in full swing. So organizers work hard to fulfill this FDP to this extent. So a special appreciation to Dr. Muhammad Mansoor and Professor Tasneem for their tireless effort to bring the FDP to this much success and for selecting such a nice topic. And also I'm welcoming the coordinators to this function. And the highlight of this is out of the 40 participants, the 35 of them are externals. So we got a good reach of the program and sufficient delegates and participants. So I'm welcoming all the participants to this function. And other than this, our department faculties, staffs, and all my friends are cordially invited to the function. And a warm welcome to all. Wish you a good day. Thank you. Hello.
Yes.
Shreya. So the welcome session is over. We can continue.
Thank you so much, ma'am. Now moving on to give an overview of this faculty development program, I would like to invite Dr. Mohammed Mansoor O, Assistant Professor, Department of Electrical and Electronics Engineering, TKM College of Engineering, and a coordinator of this program. So please.
And all. Okay, this FDP is organized in hybrid mode. So, faculties from University of Brunei, industry, and NITs are joining with us during these 6 days. So, mainly we are focusing on machine learning for various engineering applications, data collection, everything. Then hardware implementation and closed loop things related to Powertronics, so that hardware experience you can obtain tomorrow and day after tomorrow. All these things are telecasting through Zoom platform. And finally, we can have 2 eminent faculties from NIT Calicut. They are giving a brief idea about state vector modulation and machine learning applications in various fields. And last day, mainly FPGA programs, FPGA control introduction will be there, and followed by a lab section from University of Technology Brunei. And by joining all these sections, you will get a better insight in machine learning and embedded system applications in various fields in engineering domain. So thank you.
Thank you so much, sir. Let me now invite Dr. T.A. Shahul Hamid, Principal, TKM College of Engineering, for the inaugural address. So please.
Yeah, am I audible?
Yes, sir, you're audible.
So, Dr. Sabina, head of the department, Dr. Mansoor, Dr. Sheikh, other faculty colleagues, participants, ladies and gentlemen, good morning to all. In fact, I'm very happy to be a part of this FDP, Faculty Development Program on Embedded Systems and Machine Learning. See, this topic, as we all know, it is highly relevant. Let me congratulate the organizers, the faculty coordinators, Dr. Mansoor and Dr. Tasneem, in choosing a topic of very high relevance and choosing excellent faculty from different universities and taking pain in organizing this amidst their hectic schedule, academic schedule. In fact, as we all know, the industry readiness is very important attribute to be embedded in graduates. And this is not that easy to embed this attribute to graduates. It requires some planned efforts by the academic community. And as an autonomous college, we are planning to include targeted programs for certificate programs, certificate courses, and targeted programs for faculty training. And our effort is to make our graduates industry ready. As an autonomous college, we have many avenues to cooperate with the universities outside. And I'm very thankful to Dr. Sheikh, who was once a faculty with our institution. And he is extending his support from University of Brunei for organizing such events. Thank you, Mr. Sheikh Mohammed. And as we all know, we need to travel a lot more to meet the industry demands. That's why in our curriculum, forthcoming curriculum of autonomous batch in 2024, we're going to join in 2024, some innovative courses are being tailored for them. So these kinds of faculty development programs would surely invigorate our efforts in this direction. And I'm very happy to be a part of this. And I'm very much interested on the topics described by Dr. Mansoor. If at all I get time, I would join sometime in these 6 days. I wish this program all success and I declare this open. Thank you.
Thank you so much, sir. I now request Dr. K. Vijana Kunju, Professor, Department of Electrical and Electronics Engineering, TKM College of Engineering, for the felicitation. Ma'am.
Yeah, good morning, everyone. Hope I'm audible to all of you.
Yes, ma'am.
Yeah, okay. It is a very great pleasure to have such, cutting edge technology problems being analyzed under the faculty development programs, because basically all of our researchers are moving towards applying such tools for their research. And when we see that when our students, undergrads and postgrad students, when they try to apply the same, they lack the gap between how to implement and how to actually model their problems. Basically in electrical engineering, we know that this is being applied mostly in power systems plus instrumentation and the control systems, etc. So when they try to solve the problem and try to design their problem and try to implement it into the embedded systems, they lack the connection between the two. So we always wanted to have a program wherein they'll be learning how to model, how to adapt this into the software, and then how to link the software with the hardware, and then try to develop a complete product which involves the embedded software plus the hardware for that. So I'm indeed glad that the team behind this program has been successful in implementing the whole with their schedule, with making use of the hybrid modes. And thanks a lot to the University of Brunei for supporting us in all our endeavors, right from last IPEX 22. We have been collaborating with them, and this has been successful due to the shifting of our own faculty member Sheikh to the University of Brunei. So we thank University of Brunei as well as Dr. Sheikh for supporting our college and collaborating with us in setting up such a wonderful technical event. And we are very much sure that this is just a beginning of the whole research collaboration between the two institutions, because we have been trying to make use of the research guides also as co-guides between the two universities. So we look forward for much more avenues in collaborating between the two institutions. Only then we can get a complete meaning of being an autonomous institution and give more benefits to our own students. And we are very much happy to have the support from our principal, Dr. Shahul Hamid, and our head of the department, Dr. Sabina. And great congratulations to the organizers, Mansoor and Tasnim, and all the best to all the delegates. Thank you.
Thank you so much, ma'am. I now request Dr. Sheikh Mohammed S., Assistant Professor, Faculty of Engineering, University Technology, Brunei, and Coordinator of the program from University Technology, Brunei, Brunei Darussalam, for the felicitation. Sir, please.
Thank you. Am I audible?
Yes, sir, you're audible.
Oh, that's great. Assalamu alaikum and good morning to all. First of all, I would like to thank TKM College of Engineering for giving us an opportunity to bridge the relation through the technical events which we are conducting based on our MOU. I would like to thank Dr. Shahul Hamid sir, Principal TKM College, HOD Dr. Sabina ma'am, Dr. Vijaya ma'am, and the organizers of this event for inviting us to collaborate and to share some sessions by our faculty members. Also, I would like to take this opportunity to thank my colleagues, Professor Adil Al-Jumaili and Dr. Ahmed Azlan, who have agreed to deliver their sessions during this event. Last year, we have collaborated for IPEX 2022. It was really a great success. And this time we are coming up with a new collaboration for conducting a joint event of FDP titled Embedded Systems and Machine Learning for Engineering and Applications. We expect more to come and more to collaborate in future. In addition to that, I would like to inform that our student internship program is open for the international students, and TKM College can initiate and communicate with Corporate Communication Office of UTB if you have any plans or willing to send students for their 2 to 4 weeks internship program to our university. Once again, thank you all for giving us an opportunity to associate with TKM College of Engineering for this wonderful faculty development program. Thank you all. Thank you so much.
Thank you so much, sir. Now, to deliver the vote of thanks, I would like to invite Professor Tasneem A., Assistant Professor, Department of Electrical and Electronics Engineering, TKM College of Engineering, and the coordinator of this program. Ma'am.
Okay, thank you. Am I audible?
Yes, ma'am.
Good morning, one and all. Respected Principal, HOD, faculty and staff TKMC, faculty UTB, and participants of this FTP who are joined in online and offline. I'm pleased to be standing here on behalf of organizing team of this FTP. First of all, I thank our respected principal, Dr. T.A. Shahul Hamid sir, for accepting our invitation and being here with us today. Thank you, sir. Dr. Sabina Bibi, our HOD, deserves special thanks for her constant support and guidance in organizing this FTP. Thank you, ma'am. As mentioned earlier, this FDP is organized under TechCube 2 in association with University Technology Brunei as part of MOU between EEE Department TKMC and UTB. In order to sanction this FDP as a fruitful collaboration of this MOU, Dr. Sheikh Mohammed Sultan, our former faculty, now faculty at UTB, helped us a lot. Thank you, sir. Thank you very much for your effort in convincing UTB as one of the collaborators in organizing this FDP. I also take this opportunity to thank UTB management, AVC Research, Dean Faculty of Engineering, and EEE Program Leader, UTB, to sanction this FDP under this MOU. Now I thank my co-coordinator, Dr. Mohammed Mansoor O, for the immense effort in arranging this FDP. He worked tirelessly for making this FDP in a well-organized manner. Thank you, sir. I thank my fellow colleagues and my dear students for giving all support to organize this event. Thank you. I thank all the delegates from different colleges who are participating in this FDP. Success of this program depends upon you. Thank you for sparing your precious time with us. Thank you all and wishing you a wonderful day. Thank you.
Thank you so much, ma'am. With this, we have come to an end to this inaugural session. I once again take this opportunity to thank all of you present here. I hope you all have a fruitful time and can make the best use out of this program. Now we are moving on to the first session of the day. The session will be taken by Dr. Adel Al-Jumaili. Professor, Electrical and Electronics Engineering Program Area, Faculty of Engineering, University Technology Brunei, Brunei Darussalam. The topic of the session is Machine Learning for Real-Time Applications, Considerations and Limitations. Dr. Adel Al-Jumaili is an experienced professor with a demonstrated history of working in the higher education industry, graduated from University of Technology. He is skilled in computer science, computational intelligence, machine learning, realistic humanized computational intelligence-based technology, health technology, biomechanics, lecturing, latex, MATLAB, and data analysis. He has also worked as an associate professor, Faculty of Engineering and IT, University of Technology, Sydney. Now, on behalf of everyone present here, with utmost honor and privilege, I would like to request Dr. Adel Al-Jumaili to take the session. Sir.
Thank you very much. I don't know, I think with you, good morning for us, good afternoon. I hope you are fine and doing well. Thank you for a nice introduction. I just wondering if you can see my slide.
Yes, sir. It's visible.
Great. So without further, I'm going to talk about, first, thank you for inviting me and join with you for this workshop. I'm going to talk about machine learning for real-time application, consideration and limitation. I'm not going to touch a lot in embedded system, but all my talk around that. So who am I first? Just because I think the introduction, not with the one I sent, it's a little bit old. I am a professor at the University of Brunei, Technology Brunei, and also I am holding a professor in ANSTA, France, professor, research fellow professor in ANSTA, France. I have publication more than 250, best paper award around 6. I have hold 13 patents, 12 of them fully sponsored by industry. That's include 3 international, 3 United States, 2 Australian. My grant around 7 million Australian dollar. I just moved from Australia to Brunei. Delivery more than 17 projects, awarded and prize more than 27. I supervise last 10 years, sorry, now more than 10 years, 17 PhD, 16 PhD and 1 master, another 2 is coming. I got 2 supervision awards I am involving in journals and editor-in-chief and other associate or editor position, more than 25 journals in and out, and many conferences. And I've got 6 appointments, and I have more than 7 committees. I don't want to, anyhow, just this an idea. If somebody interested about me, I'll be happy to talk about it later. I think my citation 4,500 something, and the H-index 35. I'm going to give a brief introduction, background, and I'm going to talk what the concept AI, machine learning, and computational intelligence, and what's the problem-based computational intelligence, what the machine learning implementation steps, because I am aiming for applied machine learning, and what the implementation issues. I'm going to talk about 2 of my projects, rehabilitation devices and skin cancer. Also, I'm going to include also something about deep learning, data fusion, and data augmentation. So introduction, what AI applications. I think everybody now aware that AI involved in all the details life, starting from Google search, ChatGPT, ChatGPT-3, any daily life activities, it's somehow involved in your TV, in your life, in your smartwatch, it's somehow. So what's the AI? AI stand, by the way, what I'm talking about is my definition and my understanding. So maybe some people agree, not agree, it's up to them. So what AI is stand for artificial intelligence. What artificial intelligence? It tries to provide a system, which a system can be physical or non-physical. What I mean by non-physical software, with some intelligence. So what we mean by intelligent? Okay, let me put it in different aspect. While I am trying to present, I'm going to, let me put it another side. While I'm delivering a lecture, I say a joke. So all the students, let us say out of 25 students, 23 people laugh, 2 people start to laugh after 1 hour. So as intelligence system, you should have a receiver, okay? You receive the information or the knowledge, you process it, and you act. So this 23 people, they receive the information, the joke, they process it, they understand it, and they act laughing. But these 2 peoples, the extra 2, they haven't laughed, but they laugh after 1 hour. So that's mean they receive the information, they process it, and they laugh, but there is a time delay. Are they intelligence based on the common understanding? Yes. Receive, understand, and attack. So my definition, a little bit ahead from that, we say maximizely use the given information in the certain situation. So they should start to laugh after they understand, not after 1 hour. So maximize knowledge or maximize using the knowledge in the given situation. So if we are going to talk about missile machine intelligence or artificial intelligence, that should be acted in microsecond or millisecond. If we are going to talk about artificial intelligence to control dam gates, should be acted maybe within 1 hour or 2 hours. So this is based on the application. So let us agree the artificial intelligence maximizely using the knowledge based on the given situation. So any system should have a knowledge that help them to understand and maximizely use it in the situation. Maximizely use it mean related to the real-time application. And real-time definition is changing as a time from application to application, and as I mentioned. This guide us what a machine learning. Machine learning is subdivision or sub-area from artificial intelligence. Okay, why they called it machine learning? It's same concept, maximize the using the knowledge in the given situation, but is based on using certain algorithm. So the algorithm that has been taken from mimic the let us say biological system, merely they called it machine learning, like BS or whatever the base of it. What computational intelligence is a part of or subdivision from machine learning. And this is merely also based on human biological system in one way or other. So immune system, neural network, deep neural network, whatever available is the computational intelligence, fuzzy logic, and so on. Deep learning is small subdivision of computational intelligence, which is just the algorithms that mimic how the human brain deeply understand the processing of the knowledge. What the common thing on all of them, we called them universal algorithm or universal approach. That means same algorithm working for different application with small modification. Up to computational intelligence, the mimic of the human brain just mimic the surface of the brain and convert it to mathematical model. Deep learning mimic the surface of the brain and the underneath layers. So this is, let us say, what we try to achieve. So any system that can have a knowledge or can use a knowledge and understand it and universal, no need to change a lot in it, you can use it, you can assume it as artificial intelligence. Artificial intelligence, by the way, bigger than machine learning. Machine learning is bigger than computational intelligence. Computational intelligence is bigger than deep learning. So if we look at for us as a tent or big umbrella, AI bigger, smaller machine, smaller computational, smaller deep learning. Now we will come for computational intelligence application or problems. What the computational intelligence and same will be correct for machine learning, what they can do, what the problem they can handle. They handle 4 problems. I mean, I'm not going to go for reinforcement learning. They handling classification, they handling regression, they handling clustering, they handle rule extraction. So this is the common problems that machine learning and computational intelligence can work with it. Again, is not can work with everything. There is a limitation for the work. So what the classification? Classification is separating the data and based on the requirement. Like I'm going to give image, I'm going to say, I want this to be classified to big house, let us say, small house and big house and small house. Or I want to classify this image to tall people and short people, or whatever type of a classification is a separation under coming classes that the user should know it. And this is coming so linked to the supervised learning, which come for it later. Regression is using the previous data, like previous serious time data for predicting the future in one way or other. Like I know the rental for this or the house prices. If I know this house, let me say, in 2000 was this house with a 3-bed, this is its a price. In 2000, 2001, this, in 2002, 3, 4, 5, to 2020, 23. So can I know what will be the price for that house after 2 years based on this? Again, this is a regression and part of it, what we call the recommendation system. Clustering is linked to the classification. We want the system to separate, to find out for us the relation between the data and separate it in certain way based on the system understanding. We're not going to say this is should be in this class and this is big house, this is small house. No, we tell them look for the image or this is photos and separate them. I give them 100 photo and ask them to put them in groups. So what the system going to do, like find a person sharing many photos. So they put this photos in one group, another person sharing a different photos, put it in different group and so on. This is the clustering. I'd link to unsupervised learning in one way or other. Rule extraction, I give the system information and try to find the relation. So like I go give the system, let me say, shopping list. As a people who pay on the cashier, big supermarket, they try to make the payment and they receive the receipt. So we try to find what the relation between the item the people bought it. So we'll find like whoever buy a Pepsi, buy bread with it, or buy a cola, buy a cigarette with it, whatever. So in this case, it's a data knowledge, and I going to use it, place the Pepsi next to the bread, something like this. So I say, if this customer bought this, that means he's going to bought that. So it's a type of rule extraction. So sorry, maybe I am a little bit more in details, but to give you an idea as what the computational and machine learning problems and application can handle. So general step for using a computational intelligence, first you should know this problem is a machine learning or computational intelligence or not. So if it's not a classification, not rule extraction, not a clustering, not regression, so don't jump and try to implement a problem, computational intelligence or machine learning on it. Second, you should know exactly what's the problem, okay? And try to find all the necessary elements and try to find under which area you can process it. Is it classification, regression, recommended system, reinforcement, unsupervised, whatever. But this classification, okay. How can I deal with it? This is regression, how can I deal with it? And this guides us for the next one. Never start from scratch. You should try to find what the others have done in similar area. If it's exact area, it will be great. If similar area, it will be all right. And based on that, you can pick up the algorithm that you need to work with it, because as I mentioned, yes, it's universal, but it needs some adjusting from area to area first, and second, it needs some algorithm working better than others based on the application. So in this case, what the background for implementation issues? First one, the application type. Each type maybe can fit with certain, or let me say, all of them, they give you a good result, but some algorithm give you better than others. So you should try to find what the application type. You should work with your real-time processing. Okay, if you are going to make it an embedded system, is different from using a cloud, it's different from using cluster, it's different from using your laptop, okay? And what's your data size? Because based on your data size, you can also link the processing time, link what the application you can use, and data information. Data information, we usually call it labeling. What we mean by labeling? You have, let us say, image of houses. You should, as a human, recognize this big house or this small house. Big or small mean we label. We give them a label. So we know what data type you are dealing with it. So, and the most common, most important things in any implementation here, and we always advise our researchers, know your data. If you know your data, it will save for you a lot of time in implementation. So let us come for real-time processing. There is a time limitation on the processing power. If you are targeting embedded system, you should know what's your application time required and how much processing power you have. As I mentioned, opening, closing gates take hours, not big deal. And correcting processes devices or ask processes devices take millisecond. So you should know what's the time limitation for your item and what the processing power you have or you need. Data size. The small data size maybe is not good enough for you to work with the machine learning, because what I meant by machine learning work based on training. Let me say I'm talking about supervised learning. So let us assume if you want to train a driver to drive a car, okay, teach him how to drive. If you are going to ask him or accompany him or teach him just once in the highway, you don't expect from him to be a good driver. But if you are going to teach him how to drive 10 hours still in the highway, maybe he's going to do good. But if you're going to teach him 10 hours, including urban and highway, maybe doing better. So small size data maybe is not necessarily going to make your system work. And the data type itself, how much is accurate, is not going to work. By the way, if we're coming to the driver, again, you are going to teach the person how to drive. And to certain situation, you cannot cover all the real life situation or daily life driving situation. But what you expect from him, if he or she get such a skill, so he can take action in unseen situation. In other words, if you train him with the certain situation, you expect him to take a good or correct action in ungiven or situation that you haven't taught him to do that. This is a machine learning also. We train them in certain data and we expect them to take a correct action in the ungiven situation. Data information labeling. We are going to face not labeled data. We are not sure. I look for an image. I don't know this is cancer image or not cancer image. This is not just as a machine learning, even the human, but I work with the pathologist. They classify it, they are not sure. So what they do, they circulate it between them. What do you think? They take a majority, okay? Or double labeling. What we mean, one pathologist say cancer, another one say no cancer. I'm telling you, I'm a real example, like in the United States, the HIV, the AIDS, they have 4 ways of treating, 4 paths or 4 approach. So any patient who want for any medical expert, HIV medical expert, AIDS expert, they tell him, okay, you need to take either this type of a treatment or this or this or this, 1 out of 4. Up to now, no two medical specialists agree for the same approach for the same patient. So this will be double labeling. This general information, I'll be happy if you you have any question, otherwise I'll carry on. So I'm going, any question? Or we keep it to the end? Okay, no answer, keep it to end. So I'm going to talk about real-time application for two type of projects that I can handle it. First is rehabilitation devices and system. We try to make people less severe. Okay, let me introduce rehabilitation. Rehabilitation after stroke, okay, which mean the people, if they have a stroke, half of the body paralyzed. So in this case, we need a physiotherapist sit one-to-one and make the hand movement for the patient to make them or to give indication to the brain to assign a new area to control the half of the paralyzed body. Because in the stroke, part of the human brain is damaged. So the brain should allocate a new area to do the function of the damaged area. How we do that? We make a daily life activity like open, close the hand, moving, whatever. This will help the brain to assign a new area to do that. So we try to develop a state-of-art technology on this because it's one-to-one treatment. There is a shortage of physiotherapists. We try to use or create reusable devices, especially and there is a aging population is rising and there is a high health care cost. And the normal rehabilitation, if you visit any hospital, I visit many, okay, it's very boring and the people not accepted. So the benefit, we help the patient to be more independent, live, return or make their brain assign a new area faster, return to their life, back to work, and cheap and easy to use. So this is our vision. So in this case, we need, let me just move this, sorry. We need, okay, we need to make, oh, sorry, I just would like to move this. Okay. We need to make the system work or develop devices that work based on the human intention. When the human think he or she going to move his hand, the wearable robot will going to make the movement rather than hand of the human physiotherapist. So we need to read the muscle signals, try to find out what the type of movement is he going to move a fingers, combine fingers, open and close, and do that in real time. And these devices should be cheap, easy to use, and easy to maintain. We don't want to create exoskeleton cost $250,000, which is existing. We want something wearable, cheap, and they can help the user and healthcare provider. The physiotherapy choose the exercise and the wearable robot can do, and can be used for rehabilitation as assistive devices or support the people with the weak muscle. Some people, they don't have a stroke, but their muscle is weak. We give them a strength, okay, and motivate the user, give them some motivation to do that rather than boring, and can be extended to prosthesis devices. The people who lost their arm from the phone can be used same system. So now we will come for a problem. Acceptance rate for myoelectrical control in real time is bigger problem. What we mean, acceptance devices that control by muscle signal working in real time is not that good. And accepting or the acceptance rate in a clinical application is all right because it's control environment, but in real life is not that good. So we have a big gap between the success in laboratory and the successful real life application. So we try to make, and the main things based on that, the muscle signal recognition is not easy because it will be affected by the sensor move. If you don't place the sensor exactly in the center of the muscle, okay, is that, and you place it one centimeter, the reading will be different, the algorithm is not going to work. And the limb position, if your hand change the position, is going to different. Add muscle fatigue, if the muscle tired, it's going, the reading for the muscle signal, the EMG, it will be different. By the way, myoelectrical or EMG is same, two terms for the same thing, which is the muscle signal. And while you're training, the muscle function will increase, not like when you're first, when there is no muscle signal or very small muscle signal. In this case, your algorithm is going to have a problem. And the most important part, the time limitation. So acceptable time delay should be less than 300 milliseconds. And the optimal, which should be between 100 to 175 milliseconds. What do we mean by that? From the reading, from the sensor reading to take action and make the wearable robot move to do the intended movement should be less than 300 milliseconds. So you need to get the signal, you need to process it, you need to know what is it, you need to inform the robot to move, should that be more than 300 milliseconds. Otherwise, if let me say the human want to pick up a cup, and if it's more than 300 milliseconds, the human will sense it. He wants to pick up a cup, but his hand move after 3 or 4 seconds, which is a time delay not acceptable. So this is the reason I say you should know the time limitation and the processing power you have. If you are going to have high processing power or high processing power, which is mean very high CPU or GPU, whatever, this mean more cost, okay? And if you have less, maybe you are not going to reach your time. This is the reason I mentioned always know your real-time processing for your application and also the required power processing power. So myoelectrical, which is control, which is muscle signal control, can be extended to prosthetic devices, should recognize the user intention, and it's if intention of moving detect, the system should recognize the intended movement and enable the hand exoskeleton to assist the user to move the individual or combined finger movement. So maybe we have a problem here. Maybe the user not moving one finger, maybe many fingers, combined movement of the fingers. So the system should aware about that. The system should recognize the individual and combined movement before the hand move using minimum sensors, which is we have here limited to 2 sensors because we want less cost and get a good accuracy. And this guide us for another problem. So we use here 2 EMG channel. That means we just use 2 sensors and should be work with the required time required. So based on that, we built a system that can handle with just, this is the left image is just a little bit old sensor. Now we have very small sensor just to show you where we place it. 2 sensor, and in real time, in less than 300 milliseconds, we successfully recognize 10 movements, each finger alone, combine fingers and close and open the hand. And we use data acquisition, pre-processing, feature extraction, feature reduction, classification. I'm not going to talk about each of them because each of them is important, but pre-processing is the most important part, and the classification algorithm also important. I'm not going to go for each of them, but pre-processing, cleaning the data, feature extraction, get the representation of the data or get a group of data that represent all the data, or and still give me a good information. In other words, feature extraction, pick up a small portion of the data that represent the big data with enough information. In other words, if you are going to monitor air condition and you are reading in each 3 seconds, and if the temperature has not changed, so the voltage reading voltage for changing the temperature is same, so you don't need to handle it. When it changes, you pick up it. So the change will be enough for you to deal with the system. So you don't need to deal all of the data. So this is one. And the classification, you should pick up a system that can act in real time and in very limited data. And based on that, we use a extreme learning machine, which is a special type of machine neural network that need a minimum training. So our best feature, the best feature that we found, which is this waveform length, sloping sign, is just what the feature is, just a mathematical equation representing the data. Okay, so we find these features that can deal with it, and the window for reading should be, because our target should be around 200 milliseconds, we say less than 300, the ideally up to 175 milliseconds, so our window was 100 milliseconds. So we utilize for feature reduction, linear discriminant analysis. We utilize also spectral recognition discriminant analysis, SRDA, STARDA, and we develop extreme learning machine and spectral regression extreme learning machine, which is a new type of should be ELM improved by this one. So after that, we find the extreme learning machine should be doing well, but not the common one. So we try to use a kernel based, which is equivalent to support vector machine. We used a different type of machine, extreme learning machine, and we develop our own type to matching the requirement. So we develop also, as I mentioned, SRD, ELM, we develop swarm ELM, based on the BSO, particle swarm optimization, and we develop wavelet ELM also to improve the swarm optimization. Okay, why I mention all of this? Because as I mentioned, you have a limited time, limited resource. You cannot use deep learning in such situation. So you should find out the best algorithm that fit your embedded system. Okay, and the main things we also develop adaptive wavelet extreme learning machine, AW, which is we found it is better than wavelet extreme learning machine. And this is offline. For online, we develop online sequential extreme learning machine and semi-adaptive pattern recognition system. And based on that, we successfully done classification. But sometimes we receive more than one answer. So we use majority vote as post-processing time. So the result with the smart optimization, we reached 90 with the kernel, because we say there ELM, even it's like a neural network, but there is a type of it similar to support vector machine has a kernel. We reach 94% accuracy. Okay, and here I'm not going to do that. You can find it in my publication. Okay, for online and offline. Here, steady state, that's mean the human not moving his hand, just put it at the table and do the finger movement. While transition mean the moving his hand and act normally. And this is a classification. I'm not going to do the result, but we done it in daily life activities, daily based activities with online, and we get around 85% accuracy. This is a little bit old, and 89 offline. And we also develop after that many systems, and we do it with non-impute and impute. What we mean, people lost their hand from the form, and the people just don't lose their hand. By the way, if the person lost his hand, up to 3 years, he or she can remember how to move, imagine how to move his finger. After 3 years, we cannot use this system. We need to ask them to go through virtual reality, special training, so they can imagine again how to use their finger or moving their fingers. And here is a general classification, general method that we used, and the accuracy we found. So this work has been done for amplitude and non-amplitude, and using machine learning, extreme learning machine approve it work, and it's approved better than support vector machine, less secure support vector machine, k-nearest neighborhood, and linear discriminant analysis, and even an older non-correlated linear discriminant analysis. So in this case, we got the best one, advanced online sequential extreme learning machine, adaptive wavelet, and we published, this is old, we publish an IEEE transaction, and we publish a neural network, and we publish also in biosensors, and we publish International Journal for Electrical. This is, I think, the updated 2019, and we have now moved for hardware implementation. This is first application. Second application is about trauma. I don't know if you can see my hand. Okay, trauma, people with Alzheimer, they move their hand unintentionally. Okay, so can we detect this movement before it happens and dump it or control it? So this is the main idea. And as I mentioned, trauma is neurological disorder characterized by moving the hand. The idea can, because the people can move their hand as intended movement. They move while their hand vibrated. So how can we separate that? Can we know the intended movement from the unintended movement and act with them in real time? This is another big problems, and it's need a lot of information. Nobody done it yet. Okay, so, and what's the best to do that real time? So we got an experiment. We got 7 male and 4 females, and we asked them to do certain exercise, writing, eating, up their hand, down their hand, and we record the brain. This is the task. We record the brain EEG, the muscle signal EMG. We record the movement in IMU, and we try to find which one is better. And we use same thing, filtering, data segmentation, feature extraction, but we use a spiral filter, time domain, dimensional reduction, classification, and normal classification. here we're facing bigger problem. The data that we receive is not enough. So we thought about how we can increase the data without increasing the sensors. So this is, we come for another one, for another method, which is, we call it virtual data or augmentation of the data. We create a new channel, a new sensor information based on the to combine maximum and minimum of the other two sensors. Okay, combine, take the maximum of one of them minus the minimum, and we are going to classify it as a new sensor reading. And by this, we increase the data without really increasing the real hardware we deal with it. So we got a good result, and we can classify to low, moderate, and severe trauma or vibration of the hand. And we use just 8 giga RAM. And this is a type of data we receive it, and we done it with the different type of classification. And we approve that our one, this is a type of we classified based on the features, which feature or which part of the data we can use it, give us better information than the others. Okay, and we got the accuracy based on ELM, extreme learning machine, support vector machine, linear discriminant analysis, and we found most likely extreme learning machine has less power processing and get a good result. After that, we thought, okay, can we do that? Because this is a big problem, it's not easy to solve. Can we take from deep learning techniques or algorithm, and we implemented what we call the normal machine learning. Some people now they call it shallow learning, and can solve the problem, because this in deep learning can be solved. But the problem is need a lot of data, need a lot of processing power. So, and this, what we have done, we got wavelet scattering transform, which is recent development and deep within a deep recent development, but it's not deep learning method. And we get it and replace the CNN, convolutional neural network, and make it work with it. And we published that in honestly almost I think October or November of 22 on IEEE Access, and we publish also some other publication with this area. I don't want to go for more details. Now I handled the real time. Now we come for the small data and labeled, unlabeled data. So the research aim, I have a cancer, skin cancer data. I'd like to recognize this is image is cancer or not cancer. But we are facing a big problem. First, a limited availability of labeled data set. Okay, as I mentioned, same pathologist in the morning can classify differently or wrongly from afternoon or when he or she tired, and so on. Different people classify it in different way. And the data itself, we don't have a big data. So can we do something about that? Especially in histopathologist image. I'm going to say what the histopathologist image now, or let me say it now, is the image under the image of the skin under microscope, which is maybe can multiply by 100 or 10,000 times. Okay, can we trade off between using very complex algorithm and let us say less complex algorithm and get a similar result? So this is the idea. We have a limited data first. We have a data that a limited knowledge about it, or available labeled data set, limited available data set. We have image, we are not sure about it. Is it cancer unlabeled, okay, or double labeled? And we try to avoid a complex machine learning system. So we'll come for the segmentation. The segmentation, first of all, for image, we try to find the area of interest. So all of this is a skin cancer image, but digital image. So it just normal image. Okay, we try to find what is the cancer, which part of the image we can handle it. Sorry, I'm talking because I'm not sure about your background. Try to make it as easy as possible. Especially the image maybe when they took the image maybe don't have enough light, or they should be multiple color or multiple lesion nearby. What we mean maybe different texture of the skin at the time. So skin cancer can be identified A, B, C, D. A is the asymmetric, it's like a mole, okay, but has asymmetric borders. B is the size, it's bigger than normal mole. C is a color, is darker than normal mole. D is the dimension, is a different dimension. And the other thing, also, if you have more than 100 mole in your body, you should go to specialist to check if you have a cancer or not. And this is an image for a pathologist image, which is the nuclear or the cells of the skin is different. And as long as the skin cancer cells is close to the surface, we don't have a problem, because if it removed, early diagnosed and removed, the person can survive. But if come to the veins or the blood streams, it's going to go to other places of the body and cannot survive or will die from the cancer. So skin cancer, around 95% can be survived if diagnosing early. So can we help that? Can we do that, especially for normal or skin? See this one, I don't know if you can see the cursor. This nucleus is bigger than normal. So that means it's almost likely to be a skin cancer cell. So what we have done, we try to deal with the minimum data by bootstrapping algorithm that mixing like 10 off, okay, mixing the data and generating new data. And we generate two types of training data, and we have a test data. So we have deep belief neural network, the advice support vector machine, and for both of them. We developed here a new special type of support vector machine. We called it advisable support vector machine, first stage. After that, we called it self-advisable support vector machine. And based on that, we successfully get good result with a small data or double data, the double labeled data. So we developed semi-advised learning model for automated recognition of skin cancer based using histopathological images. We have efficient use for unlabeled, unlabeled. We make the system try to label the data. What I mean, if we are not sure the image is cancer or not cancer, the system try to find it, how much close to the cancer image and how much close to the non-cancer image, and say this can be cancer or not cancer. And based on that, try to classify it. And the training deep belief neural net, we call, as mentioned in the figure, divided to two stages: deep belief neural network with the unlabeled and deep belief neural network with labeled. After that, we make the training. So advice support vector machine. Advice support vector machine, what's the idea about it? The data that cannot be classified, we re-enter it again to the same support vector machine, to the same classifier, but we are going to tell the system this has not been classified, but may be closer to this. So we ask the system to classify it again by itself. And we built algorithm, mathematical algorithm by that. And this support vector machine approve it work. And the weight that we give it for unlabeled, okay, and outliner data, the data is not that with the coming, let us say, coming labeled or labeled is a little bit strange. We limited that and we make weighting or multiply by weight, and we successfully done that. So and we published some previous work about this methodology, and we still continue to use same method. So semi-advised support vector machine, and also self-advised support vector machine for many applications. This is first time we published a self-advised support vector machine in 2013. After that, we publish it, and we recently use it also for autism application. This is move us to autism application, okay? And the autism, still what we mean by autism. Autism, the people, the kids that have a visual impairment or they don't have a good communication skill based their autism. So in this situation, we don't have a lot of kids. They have autism, so we can collect the data and we make it work. First, don't have a lot of kids. First, second, is not easy to communicate with the kids, ask them to do certain experiment so we can collect the data. So the idea about this, can we get a new data from small data for the kids that we ask them, like we take 5 or 10 kids, and can we build a big data and make it work? And what's the best algorithm in real time? So this is also based on limited data and limited processing power. So what we've done, we got, I know that somebody may be going to say, now you have in deep learning, you have a neural augmentation. The system can generate for you thousands of data, but we've done something better and easier. We get a data augmentation, we get the data itself, and we augmented the feature, not the data. We augmented the small portion that represent the whole data, and we built algorithm to generate the data. So we use, why we need that virtual symbol generation? Because we need a big data to make it work for us. So like this image, okay, you can see in the down left and right, same image, we move it in different direction and close, zoom in and zoom out. And based on this, we can get a new image, but still represent the old image. We haven't created a new image. We just manipulated the original image to increase the numbers of images. So based on that, we got our own data, the real data, and we make the training and increase the virtual data or increase something representing the real data, but in big quantity. So we got class A, class B, we mixed them and we got a new data, and we tested in many data sets, medical data sets. We tested with RCCA media autism data. We tested with e-colony. We tested with the breast tissue cancer data, and we tested with our own collecting data. And it's approved that our accuracy with virtual sample generation is much better in many cases than with the normal data. So this increased from 75% for the same data to 89% with the same classifier, okay, with the same type of data, but we just add some virtual sample generation. And you see all of the data has been, all the accuracy has been increased. And we published in 91 and multimodal, this is the main one, sorry, 21. And we published in 20 and 19 this about this method and different application. The third one is about, okay, biomotion. We have a device, this is around 50, less than half a meter, sorry, around 40 centimeter. It's a type of radar that Doppler radar, or we call it dual pulse Doppler, which is a small radar producing two signals, two ultrasound, the shift between them 90 degrees, and we place it next to the patient, half a meter to 3 meters from the people who sleeping and have a sleep apnea. Sleep apnea meaning the sleep disorder, a type of sleep disorder that the patient or the human stop breathing. And in normal situation, the brain maybe can take activity, and sometimes for a lot of old people, they will pass away. And some people, they thought they come and they say he passed away safely while he's asleep, he or she sleeping, but in reality, he passed away suffering because he stopped breathing and the brain couldn't take action. And most of the people who have sleep apnea, they are not aware about it, okay? But it reflects in their daily life, like they feel sleepy, they can't concentrate, they sleep during the work, they sleep maybe sometime during driving, even in seconds. So this is the sleep apnea. So we took these devices and try to find out if the people, can we monitor the people without a sensor? This is a type of embedded system. How we can collect the data with non-contact sensor. The sensor is not contact to the human body, okay? So we have 24 chronic heart failure people, and we have class 1 and class 2 heart failure. And we try to find out the average age is around 98 and 69 years old, and the average weight around 87 kilo, and the average monitoring about 8 hours. And we try to find out, is that one can give us same information, same for the device that have 14 sensors linked to their body. And we done that through develop a new data. We called it the 3-dimensional feature representation and extraction. So we have 2 ultrasound signal. The signal one is sent to the human body and come back. We try to find out, based on this signal, we can find the heart rate, how much oxygen in their blood, how much air in their chest, and how much and which direction they are asleep. Are they sleeping on their back, or they're facing down, or their right side, on their left side, because this affects all of it. So based on that, we got novel 3-dimension feature representation, okay, based on spital dimension transform and spital dimension decomposition. And the idea behind, guys, can from non-contact sensor get same result from contact sensor with the minimum contact and most comfortable to the people as embedded system. And we done our own algorithms. And based on that, this is, I don't want to go for mathematical model for that. We done that one. If you can see, this is a representation for Opera House of Sydney. We manipulate the data and we reconstruct it. in a 3 dimension. This is 2 dimension. We reconstructed in 3 dimension through our system. And by that, we increase the data. We increase the data size and representation. And based on that, we got the respiratory, the breathing rate, and the heart rate, and we got a very good result, which is reached 91%, almost 91.5%. We get heart rate. This is the respiratory breathing rate. This is the heart rate, is almost 91% also. We get both of them with the minimum error around 0.5, which is around 95%. We got a tidal volume, mean how much air in their chest with non-contact sensor, and we get accuracy up to 83%. And we got a body orientation in which part, let us say, how they sleep. They sleep on the left side, right side, up side, down, facing up, facing down, and we got almost 100% for their body orientation while they are sleeping. Okay, and utilizing extreme ventilation model and MLP, neural network, we test the oxygen saturation level for 45 hours, 15 minutes, and 31 seconds. Oxygen saturation level, how much oxygen in their blood. So we got around 93% accuracy. And this is oxygen saturation level that we got. And also we utilizing extreme ventilation, 3-dimensional models for the same, and we got up to 95%. And this is the result. Okay, and we published some work in IEEE sensor, we published in Procida, we published in big data, conjunctive computing, and there is now recent application with IEEE transaction biomedical journal. This is for normal learning. We come for deep learning. Deep learning, as I mentioned, if you are going to consider it in embedded system, it's need high class, let us say high power or computational power. So there is other way, which is a simplified deep. Okay, I'm going to simplify deep learning, which is they called it TennyML or Tenny machine learning, or there is another simplified machine learning that can work with the embedded system. So what I meant by here, becoming the classifier that matching your application is a big important. So your application and your computational resource. So everybody like a deep machine learning, but it has its own requirement. So you should know what the people have done, what they develop, and how you are going to deal with it. What's the difference between deep learning and normal machine learning? Normal machine learning, we need to engineer, find by hand the feature that we are going to deal with it. But deep learning, you don't need to do this stage. It will generate by itself the feature, or it learn the required feature. Sorry. So this is the difference. So to avoid the deep learning, the all training, there is a concept we call it transfer learning, which is you are going to take already developed and trained data, a trained neural network, deep learning neural network. You are going to remove the first layer, the input, and the last layer, the output, and put your own algorithms, and should work for you. Okay, now we have a problem about multimodality, which is mean two things. The human have one brain And by this brain can handle many things, can see, can test, can think, can act, can learn. Okay. The systems also should handle same thing. Okay. But again, each model is a different. We're facing another problem. The human never ever take an action based on one input. So maybe the human sees something, but also hearing another thing. So mixing the data to take a decision. While most of the machine learning is based on one type of input. Image of cancer, emails, spam or not spam. So the idea now, how we can build multi-modality, how we can get like a biological sensor, brain sensor, muscle sensor, behavior of the human, and mix them all together to make or to take a decision or to learn. So this is a new area that should everybody working in embedded system should try to move ahead about it and try to find out how can multi-input working together, especially if the inputs is different. The amplitude or the signals of EEG and voltage and frequency different too much from the muscle, the brain from the muscle, from the behavior, how the person behave. So we should try to find out how we can use that one. So can we, let us say, embedded, or can we make all together the image and the behavior and the signals, muscle signals, put all of them in one fusion, in one, make them as one input in tensor multidimensional array or matrix and deal with them. This is a new area. And as we mentioned, if the human, there is a part of the human brain in charge about about the sight, how the person can see, a processing of the eye data. But they found if they remove the eye, still the human can see through his sensing, can imagine the see. This has been implemented in animals, not in the human. So still can use a different sensor to do same experiment for the same processing area. So this is the concept also. Can all different type of data on different type, I mean data is mean different representation, different in voltage, different in reading, like EEG have 3 types, okay? ENG have a different, all of them chiastics. Can we make them interact? And can we this work as a tensor? We mentioned multidimensional matrix and find the relation between them so we can jointly build the system. And can we make that working for trauma or COPD, another type of breathing problems? And the idea is to, let us say, re-inverse the speech recognition. What we mean, well, in the speech, if you are going to hear a different people, when you are hearing, you are mixing all of them. Can we separate them? In speech recognition, we try to separate different signals we receive to its original. Now we would like to work via verse. Can we mixing the data that we receive and get a new information and representation? So this is, I will stop here. A conclusion, machine learning, deep learning, enter all of the life. It has unlimited application now. It's enter in daily life activities. It consider like a recommendation system, consider even something the human cannot aware about it. It's improving but real-time application, which is linked to your workshop, embedded system application, is still far from existing. Clinical trial or lab control environment trial may be success, but when it comes in real time or real life, still there is a big gap. Can we fill that gap by considering the application type, the data that we work with it, the data source, the labeling? In conclusion, my advice, know your problem, know your data, clean data, good result. More data, better result. Mixing type of data give you better result. I done a lot of work and I try always, I say, minimum reading of the data. Can I give me a better result? Sometime even I got a patent, we couldn't move it to the real life application because not high accuracy. So more than one type as a human work can maybe give you a better data, but better decision. But again, can you get it or not? And what's the trade-off? Can you get less data and reach accuracy 85% or get more data, more complex system and get accuracy 87%? Maybe you are going to say, I sacrifice this 2% extra because for real human comfortability and human accepted for daily life activity. Sorry to take all of this time, but thank you for you and thank you for my team for working together. And I think I stop here and happy to work with you or answering any question.
Any questions from audience?
Hello, sir.
Yep. Hello.
I'm Dr. Sabina. I'm the current head of the department. So we got a wonderful presentation and we are acquainted with the data fusion technique and spatial dimensional transforms. But I do have some queries, sir, regarding the LDA with swarm optimization. So what is the purpose of applying swarm optimization in LDA? Is it the further reduction of dimensionality?
So sorry.
Swarm optimization with LDA.
Yep, for ELM. Sorry, I couldn't hear you. So you are asking about particle swarm optimization for extreme learning machine?
Yes, sir. Yes, sir.
Yeah, we try to minimize the training, the weight. You know, as a neural network has, each of them has a weight, okay? The connection, we try to minimize how we're reaching the optimal weight for a neural. And for this is the non-kernel. For the kernel one, we try to find out the best kernel factors in the fast way, because our aim to make the ELM working faster than a normal situation.
Okay, okay, sir.
Please back to my publication. I'll be happy to answer any question if required or provide more elaboration about it.
Okay, okay. And regarding the histopathology images, so the nucleus, what are the different characteristics you are identified for that skin lesion? Is it the division count or the size of the nuclei?
Okay, for the nuclear, as I recall, we're looking for three things. By the way, I'm not pathologist, I'm engineer, but this is the device for pathologists. When we go to him, they're looking for the size of a nuclear, how far from the skin, from the surface of the skin, because usually they take a layer from the skin, okay? What I mean, layer from the surface skin moving to the depth. The idea behind that, after the surgeon remove the skin cancer, they try to find out if they remove everything or still part of it inside the human body. So they send this skin sample to the pathologist for testing. So the pathologist looking for three things, as I recall: the nuclear size, the how far from the skin surface, and how much the mass of it, because not just as the size, the mass of it. Sometimes it's a big size but less mass. I don't know if you got what I mean.
Okay, okay, sir. Okay, sir.
Any
Okay.
other queries? Any questions from audience? Any other questions from audience? Okay, sir. So I would like one thank you for Dr. Adel Al Jumaili for giving an informative session on machine learning for real-time application. Nowadays, all researchers are concentrating on various machine learning algorithms, improvements of existing algorithms, etc., etc. So a better insight to classification, generation of samples for training data were explained in this section clearly for various engineering applications. Sir also explained novel technology for contactless and measurement of during sleep time. So through these, I hope this section through these sessions, researchers and faculties get an inspiration to apply the machine learning tools for various applications of their own interest. Thank you, sir, for accepting our invitation and delivering a wonderful, fruitful section on machine learning for real-time application. Thank you, sir.
It's my pleasure. Thank you very much. I'm sorry, maybe I don't know the background, but I try to make it as clear as possible. But again, as you mentioned, the embedded system need to aware about data collection, data acquisition, which is we try for such applications. Sometimes it's better not to contact the human body or use a minimum sensors or based on your application. Second thing, processing time and power and available data. So I try, which is in general, this what the embedded system engineer or researcher should take it in account. Again, thank you very much. Appreciate it.
Thank you, sir. Thank you, sir. So for audience, next section will start at 1:30 p.m. sharply. Through the same link, you can join this session. So thank you all. This section is going to finish.